Something called polarization analysis to figure out which direction the waves are coming from. And by doing that, we can do the same thing that we can do with 3 stations on the Earth, just using the P and the S waves.
And very quickly, there is still another instrument built by DLR that's also being carried up by InSight. Can you talk a little bit about that?
Yeah, that's our heat flow probe, and it's a pretty cool instrument that uses a mechanical mole, we call it, to burrow its way down into the surface. It has a motor with that winds up a hammer, and it knocks itself down just a few millimeters at a time. But we do that 20 or 30,000 hammer strokes, and it gets us down. We hope to get down to be about 16 feet below the surface. And once we get down there, we're actually measuring the heat coming out of the planet by measuring the temperature along the cable as it comes up to the surface, and looking at how that temperature increases as we go down, and extrapolate that deep into the planet to understand how much energy there is inside the planet to drive the geology and to drive volcanism, Mars quakes, all kinds of activity.
It's amazing how much you'll be able to learn from the surface about the interior.
That's right. I think it is amazing, and it's been something that I've been working on for my whole professional career, and it's just, I find it fascinating. But
all right, we'll talk about that. Thanks,
okay.
Bruce. Bruce first thought of a mission like this, as he mentions, 40 years ago when he was a graduate student. The rest of the team hasn't waited quite that long, but this is a big moment for them too. Recently, we sat down with a few of the members and asked them, what is it going to be like as we get close to landing?
It's a very difficult thing to do, and everything has to go perfectly. As humans, we've sent 17 different missions to the surface of Mars, and 10 of them have crashed. Before we can land on Mars, we have to get to Mars. How do we get to Mars?
The main responsibility of the navigation team is to ensure that the spacecraft is delivered to the right point at the top of the Martian atmosphere. The target location is about 12 kilometers in size. Our accuracy is comparable to shooting a basketball from Staples Center in downtown LA and hitting nothing but net in a basketball hoop in New York City that is moving at a speed of about 2 feet per second and is spinning about its axis.
The landing site, we have an ellipse that's pretty big. It's about 60 miles long. We could land anywhere in that ellipse. There's a chance that we could land right on a rock, and we don't really have any control over that, so that's what makes me nervous.
We've tested the radar by flying it on a helicopter. We've tested pieces of the heat shield by putting them in an arc jet facility. We've tested the parachute by testing it in a wind tunnel. And putting all that together in a very tightly controlled sequence where every single thing has to go right, we've never tested that. And the first time it's going to happen is once you deliver us to Mars.
It is about 11:29 a.m. Pacific, and you're watching live coverage of the InSight landing from NASA's Jet Propulsion Laboratory in Pasadena, California. We are about a half hour away from landing, and people all over the world are watching. Take a look at a map that we have for you. We can show you right now. This is a watch in person map where people have watch parties all over the world, all over the United States, in Paris, in Berlin, even off the coast of Madagascar. And folks in the Big Apple will also be watching today. The NASDAQ Tower will switch over to landing coverage for about an hour. That means people in Times Square can watch too. And later today, NASA will have the honor of ringing the closing bell, and that will be a little over an hour from now. And if you are watching, take a picture and send it to us using hashtag #MarsLanding. Here is one. I believe it is from the California Science Center in Los Angeles, and I am told Mayor Eric Garcetti will be visiting later today. Things are getting more active for the team now. Let's check back in with Julie Wirtz-Chen in the control room. What's going on, Julie?
We've heard from MRO a couple of times. That's Mars Reconnaissance Orbiter. They are doing their slew. They're ready to support us. They're doing great. And we heard from both Marcos, Marco A and B, that they're out there. We've got telemetry lock with them from the ground stations here, so they're doing great. And everybody's ready to go. So we're pretty excited.
Fantastic. We will check back in with Julie in a moment. Meantime, this is a good time to tell you a little bit more about that technology experiment we've been talking about, Marco. As we mentioned earlier, InSight does not have an orbiter in position to send EDL data back live. So the CubeSats hope to fill that gap. Here's how they'll work.
Communicating between Mars and Earth requires a complicated choreography, with everything in the right place at the right time. Sometimes hours can pass before information is relayed from one planet to the other. That's why when NASA's Mars InSight lander launches this year, the rocket will carry 2 tiny satellites on a technology test of their own. Meet Mars Cube 1. Marco, NASA's first CubeSat mission to deep space. These briefcase-sized satellites will travel separately from the InSight lander while they test out new miniaturized technologies. And if they make it to Mars, they could relay information back to Earth about InSight's descent and touchdown, and do it in mere minutes. Although this fast communication isn't crucial to the success of the InSight lander, this CubeSat test could change the way future spacecraft phone home.
All right, let's check back with Julie to see if the Marcos are indeed ready to support and listen for InSight. Julie, what do you know?
So they are ready to go. I haven't heard about their slew coming up yet, but they are ready to go. We've heard from them. They're both healthy and they're both doing great, which is just wonderful news. So I think they should be doing a slew in just a minute. Actually, yeah, I think they should be doing a slew in just a minute.
We'll stand by and listen then.
Oh, they're separated? Oh, no. You got me going until I spun it.
All stations, this systems, we can confirm we are entry minus 20 minutes. EDL nav 2 has been initiated. The star tracker has been powered off.
The nav2 software has been initiated. So when we're in cruise, we use a star tracker in a similar manner to how sailors navigated years ago. We look at the stars and get our relative position from them. And we use a star tracker for that. And now that we're close enough to Mars, we don't need that anymore. So we're going to transition to what's called nav2 software. And that lets us basically just use velocity and acceleration from this point on. So we don't need the star tracker anymore.
Slew to EDL bent pipe mode.
Marco, clarify. Slew to inertial or started bent pipe?
Slew to appropriate attitude for bent pipe. Bent pipe mode will be entered shortly.
Okay, thank you very much.
And that was obviously our confirmation of the slew for Marco, so that's great news.
Fantastic.
So I was saying before that the nav2 software will propagate from here on out, and we'll use velocity and acceleration. So we have powered off our star tracker, and we're on our nav2 software, and everything's looking great.
Okay. Thanks, Julie.
Thanks.
All right, the cruise stage separation is just about 4 minutes away, and Rob Manning joins us now. Rob is the chief engineer here at JPL and an absolute veteran of Mars landings. We're going to play a little video for you right now. You haven't seen it yet, but we'll roll it. Let's go ahead. This is
Lander is still alive. 14 reports carrier lock at
that day, Rob. There you are. You were the phase lead. You were sitting up front.
Yeah. That's what I look like when it's successful.
Yes.
I hate to see what it would have been like if I wasn't successful.
But talk about that. What is EDL like? Why is it so hard?
Well, it's many years of work by many, many people who struggle to put all the pieces together, and particularly because we can't really test entry, descent, and landing on this planet. It's much more complicated. Mars has a lower atmosphere, thinner atmosphere, less gravity. You just can't put the pieces. So imagine you had a big Broadway production, but you couldn't really do the show until all the audience shows up. So that's what it feels like. So you never really know if you've really done it right.
Well, we've done it 7 times. Can we say that, hey, piece of cake, we know what we're doing?
No, I don't think so. I mean, we get better at it. There's no doubt. We've learned for both the successes and our own failures, including failures of other missions outside of this country. So those pieces come together in our mind's eye. We try to put what we learn together and just do the best we can. And if we don't succeed, we will learn, because we are collecting data on the way down. If something bad happens today, we'll be able to take what we learned. Even though we may fall on the ground after getting kicked off the horse, we'll get back up, brush ourselves off, figure out what we did wrong, and get back on the horse.
Well, there's a lot of uncertainty. Just very quickly, give us some possible scenarios of what could happen during EDL today, especially during communications.
Well, the great news about having communications, there's almost anything that go wrong. There's a very good chance we'll figure it out. But things like, the parachute has to go right. We know you don't open parachutes on Earth going Mach 1.5. 1.5 times the speed of sound. You just don't do that. You don't need to on this planet, but we have to, because if we waited any longer, we'd be on the ground. Very complicated radar system. It has to work from outer space all the way to the ground and look for the ground. What if it locked up on the heat shield? Well, we've tried to avoid that problem. We've fixed that problem, we think, to prevent that from happening. But what if we got it wrong? Things like that could happen, and our vehicle could have things bad happen. But we've worked hard to prevent them.
So
at this time, we expect
that
close.
We're going to go to the control room for cruise stage separation, Rob.
Okay.
Thank you, MRO.
I need to take off common. Yeah, yes.
InSight Systems, EDL com.
Go ahead.
On InSight Court. At this time, MRO will have loaded their electro sequences. Marco is expecting carrier lock at any time. Marco B is reported there in bent pipe. Still waiting on A.
Copy that. Thank you.
Radio Science report, UHF carrier detected.
EDLCom, Marco Alpha is in bent pipe mode. Marco Bravo has locked on the carrier. Marco Alpha has also locked on carrier.
Systems ACE on InSight Cord. As expected, the DSN has LOS for InSight Expand.
Copy that. Thank you. All station InSight systems on InSight cord. DSN has lost the X-band signal from InSight, indicated expected cruise stage separation. Standing by for UHF signal acquisition via Marco or radio science.
We are about 5 minutes from entry and have confirmation we've lost the X-band signal from InSight. This was expected because we have transitioned from the antenna on the cruise stage to the UHF antenna on board the spacecraft. Ground stations have detected the UHF signal and Marco has locked on the signal. This confirms that InSight is transmitting UHF signals as expected. InSight telemetry through the Marco relay is not expected until about 2 minutes before entry.
So, Rob, that was exactly what we were hoping to hear, that
Yes.
the Marcos are
The vehicle
working.
has also performed the turn to entry maneuver. The vehicle is turning away from a sun-pointing attitude and oriented itself to enter the Martian atmosphere.
This is a big first step. Getting the cruise stage separated. It's now, after the vehicle turns itself to the right orientation, the cruise stage is now going to be get further and further away until it's about 3 or 4 football fields away, and will burn up in parallel as the vehicle enters Mars.
And Christine mentioned turn to entry. What does that mean?
Well, it's because the cruise stage has to be pushed off to one side, like this. The rest of the vehicle has to turn to face the atmosphere and to be dead nuts on as it hits the top of the atmosphere.
So this is taking all the heat coming into the atmosphere.
Exactly. It'll be both provide a source of drag, but also thermal protection because it gets over 1,500 degrees Celsius on the top of on this heat shield. Very, very hot. But on the inside of the heat shield, it's maybe only a fraction of a few degrees above room temperature. So it's a wonderful protective device to keep our lander safe.
All right, so the next thing we're standing by for is
entry. Getting to the top of the atmosphere, gradually slowing down. Right now, the vehicle's just now beginning to, very soon, we'll be beginning to feel the atmosphere touching it. Actually, entry is above the atmosphere slightly, so it's really not until a few, half a minute or so after entry, before we start really detecting the fact that that atmosphere is slowing us down.
All right, we'll be standing by.
Yes, exciting.
Rob, now entry is scheduled for 11:47. The cruise stage SEP and the entry times are locked in, correct?
They are. They're locked in when we selected the target and aimed the vehicle very precisely. That allows us to know exactly when we hit the entry point, which is 55 kilometers from the center of Mars.
So we know those times are locked in, but what about all the other events that take place in EDL?
Reggie Science reports dropping carrier power as expected.
Marco A and Marco B have telemetry.
Just heard, both Marcos have telemetry.
They are doing their job. These small CubeSats are relaying ones and zeros with a few seconds lag from the vehicle up to these two vehicles, and they forward them back to Earth to the deep space network using X-band antennas.
And keep in mind, this was all an experiment. We weren't sure that this was going to work, but we had this need that we didn't have live communication in this particular mission.
Well, we don't really need communications. We don't need their information, except if something went wrong. We would very much like to get the data right now. We have other spacecraft.
We are now receiving InSight telemetry via the Marco relay.
It's flowing into their space. This is fabulous. That means the team now can watch the data flowing onto their screens as if they're commuting directly
This data
from the
will
vehicle.
provide detailed information about the state of the spacecraft throughout EDL.
We were on pins and needles waiting for that because we weren't really sure.
This is wonderful news. This will allow us to give some, if this continues working all the way to the ground and beyond, we might even see a first picture from the surface of Mars.
Wouldn't that be great?
Very soon.
Atmospheric entry on my mark. 3, 2, 1, mark.
Here we go.
So in a few seconds, the vehicle will start sensing the atmosphere. I said 22 kilometers from the center of Mars. And it's going to start to slow down very, very slowly at first, but then faster and faster and faster till to reaches about 7 Gs. I made that mistake on the video. It's actually 7 Gs, not 12. And so but we'll still very, very quickly slow down. And from 15...
In approximately 1 minute, InSight is expected to reach its maximum heating rate.
Oh, yes.
Plasma blackout is possible during peak heating and could cause a temporary dropout of telemetry. This could last for as long as 2 minutes.
Yeah, the gas that comes off the heat shield as it's slowing down, it looks like a meteor if you're on Mars watching the streak go by. That brightness of gas does interfere with the radio reception. And so it's possible that Marco will lose that signal while it's going through this very hot entry.
But not to be alarmed.
Not to be alarmed. It's part of the design. We completely expect it.
Radio Science reports plasma blackout as expected.
Okay. Oh, wow.
Ground stations have reported plasma blackout, still receiving InSight telemetry via Marco.
Marco Alpha has carrier interruption.
InSight should now be experiencing the peak heating rate. Portions of the heat shield may reach nearly 3,000 degrees Fahrenheit as it protects the lander from the heating environment.
That's hot.
Marco Bravo shows carrier interruption, but still in lock.
InSight has passed through peak deceleration. Telemetry shows the spacecraft saw about 8 Gs.
Marco Alpha and Marco Bravo maintain lock.
Radio Science reports carrier detected.
Yeah.
So, several different communications coming in.
InSight is now traveling at a velocity of 2,000 meters per second.
Seems to have passed this very critical point of peak heating and peak deceleration. The next big step is parachute inflation.
And you can see that on our timeline on the bottom of the screen. The next event is parachute deploy.
InSight is now traveling at 1,000 meters per second.
Very close.
Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded.
This is really good news so far.
That's fantastic.
I'm on pins and needles.
We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the backshell and begin terminal descent using its 12 descent engines. Altitude convergence, the radar has locked on the ground.
Yes.
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
Lander separation commanded. Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters, 80 meters, 60 meters, 50 meters, constant velocity, 37 meters, 30 meters, 20 meters, 17 meters, standing by for touchdown. Touchdown confirmed. InSight is on the surface
Wow. That's fantastic.
This never gets old.
No, it doesn't, Rob. Control room just erupted.
Fabulous,
Shaking
fabulous.
hands with the Marco team there.
Christine, you did great. Jim Preiser, one of the key designers at Lockheed. Sandy Krasner, what a great team. What a great. This is really fabulous.
Fantastic news.
Thank you.
Lots of fist bumping going on in there. What a relief. We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.